Hello and welcome to the new lecture session. Today, today we will discuss on a new topic, that is lean burn engine. So let's start this lean burn engine. The lean burn refers to a burning of fuel with an excess of air in an internal combustion engine. Internal combustion engine. Basically, in conventional engine using gasoline and diesel operating at full throttle employ an air-fuel mixture close to stoichiometric. For most of the hydrocarbon fuel, the stoichiometric air-fuel ratio can be taken as 15:1. Beyond this ratio, the engine begins to misfire, resulting in an unsteady combustion cycle. All world After the Second World War, all world have started pushing the automotive industry to reduce automobile exhaust emission. So this, along with the relation of diminishing oil reserve, have forced automotive designer to look at higher air-fuel ratio engine in order to increase fuel efficiency. This higher than average air-fuel ratio engines are called lean burn engines, which are being developed since 1960s. So, in a lean burn engine, the fuel must be injected into the combustion chamber where there is intensive swelling air motion. This concentrates the fuel around the spark plug, which keeps the ignition duration constant for every cycle, preventing misfiring. In order to concentrate the fuel around the spark plug, the combustion chamber should be designed in such a way that the air motion swells up towards the spark plug. At the same time, the spark plug should be placed in the center of the combustion chamber. This makes the spark plug closer to the fuel. It prevents the fuel particles furthest from the spark plug self-ignition. This means that the compression ratio can be increased and higher fuel efficiency can be achieved. The above improvement enables the air-fuel ratio to be increased, thereby decrease the specific fuel consumption of the engine by 5 to 25%. This excess air in a lean burn engine emits far less hydrocarbon. So in lean burn engine have the advantage of decreasing the emission. The amount of carbon monoxide emits is less as there is plenty of oxygen available to produce carbon dioxide. Unburned hydrocarbon emission is reduced by up to 80% in lean burn engine. This is because unburned hydrocarbons are released when combustion is not complete. Fuel injection prevents fuel droplet settling in the intake passages by spraying them directly just behind the inlet valve. This helps to produce a homogeneous air-fuel mixture. So this is the basic things of the lean burn engine. Next come to the principle of this lean burn engine. A lean burn mode is a way to reduce throttling losses. An engine in a typical vehicle which is designed for providing the power required for the acceleration. At the same time, must same time must operate well below that point in normal steady speed operation. Ordinarily, in SI engine, the power is reduced by partially causing a short. However, the extra work done in pumping air through the throttle reduces efficiency. If the air-fuel ratio is reduced, if air-fuel ratio is reduced, then lower power can be achieved even at full throttle. At the same time, the efficiency during normal driving can be higher. The engine designed for learning, the engine designed for lean burning can employ higher compression ratio and thus provide better performance, efficient fuel use, and low exhaust hydrocarbon emission than those found in conventional gasoline engine. Ultra lean mixture with very high air-fuel ratio can be achieved by direct injection engine only. So lean burn engine do not work well with modern three-way catalytic converter because they require a pollutant balance at the exhaust port so that they can carry out both oxidation sorry both oxidation and reduction reactions. So most of the most modern engine run at or near the stoichiometric point. Alternatively, ultra lean ratio can reduce NOx emission. Therefore, the main drawback of lean burning is that a complex catalytic converter system is required to reduce the NOx emission. Potential application for lean burn technology is for gas engine and electric generation. One of the benefits of this technology is significantly reduced emissions in the exhaust. New lean burn gas engine generators have NOx emission as low as 0.85 gram per hour, and it produces low amounts of hydrocarbon, carbon monoxide, and particulate matter. This allows the generator shapes to meet the most stringent air quality regulation without after treatment devices in the exhaust stream. For lower emission, lean burn gas engine generator set are frequently coupled with integrated after treatment options such as selective catalytic reduction or SCR and oxidation catalyst, resulting in NOx level at or below 0.15 gram per hour. With this after treatment option, with this after treatment option, the gas engine generators have been shown to meet the most stringent prime power emission regulation anywhere in the world. So this is the basic things. Next, the Toyota lane burn engine. A lane burn engine control system developed by Toyota is shown in this picture. It uses a cylinder sensor. It uses cylinder sensor to monitor combustion pressure. Here from this picture, number one is EFI, individual injection system. Number 2, electronically controlled valve. Number 3, swirl control valve or SCV. 4, newly designed helical port. 5, combustion pressure sensor. Number 6, electronically controlled EGR valve. 7, oxygen sensor. 8, three-way catalytic converter. 9, engine speed sensor. And 10, electronic control unit. So in the Toyota engine, it used in cylinder sensor to monitor combustion pressure and a sequential individual injection system. To control fueling on a cylinder by cylinder basis. The air fuel ratio for the engine is monitored through a wide range oxygen sensor installed in the exhaust downpipe before the three-way catalytic converter. A novel feature incorporated is the use of swirl control valve, which is mounted in the intake system. The intake track for each cylinder is divided into two passages. One passage is smooth, which allow maximum gas flow for good cylinder charging, and the other passage is fitted with a corkscrew shaped flange with the helical port. Which introduce swell into the incoming air. The engine control unit can switch airflow in one of the two tracks by actuating the swell control valve. The engine operates in a lane burn mode when it is running under light to medium load condition. The electronic control unit directs the swell control valve to open up the curved inlet passage to have well mixed incoming vapor due to the high level of turbulence to the swell. During combustion, the electronic control unit monitors the pressure sensor signal for any sign of slow or incomplete burning and then appropriately modifies the air fuel ratio using electronically control valve or ignition time on a catalytic cylinder by cylinder basis. Because of this continuous monitoring of the exhaust gas oxygen concentration, these facilities permit the engine to produce high efficiency at air-fuel ratio up to 25:1. Further, the engine speed is monitored by the speed sensor. There is also the EGR valve to reduce NOx emission. The three-way catalytic converter runs under high load condition, especially during the overtaking or high hill climbing. The ECU switches to stoichiometric operation for maximum power. To achieve this, the ECU directs the SCV or swell control valve to open the smooth intake passage and use the oxygen sensor signal to maintain the air-fuel ratio of 14.7 is to 1. So this is the Toyota Linburn engine. So after the Toyota Linburn engine, next is Honda Linburn engine. The newer Honda certified charged Linburn engine operates an air-fuel ratio as high as 22:1, using precise control of fuel injector with the strong air-fuel swelling created in the combustion chamber. It employs new linear air-fuel sensor and learned burn NOx catalyst to further reduce the NOx. The amount of fuel drawn into the engine is much lower than a typical gasoline engine, which operates at 14.7:1. This Linburn ability by the necessity of the limits of the physics and the chemistry of combustion as it applied to a current gasoline engine must be limited to a light load and lower RPM condition. A top speed cutoff point is required since learner gasoline fuel mixture burns slower. For power to be produced, combustion must be complete by the time of the exhaust valve opens. This certified charge approach to Linburn combustion means that the air-fuel ratio is not equal throughout the cylinder. Instead, precise control over fuel injection and intake valve dynamics allow a denser concentration of fuel closer to the spark plug tip, which is required for successful ignition and flame speed for a complete combustion. The remainder of the cylinder intake charge is progressively linear with an overall average air-fuel ratio falling into the Linburn category up to 22:1. The older Honda engine that used Linburn accomplished this by having a parallel fuel and intake system that fit a P-chamber with the ideal ratio for initial combustion. This is called compound vortex controlled combustion or Honda CVCC, which allow lower emissions without the need for a catalytic converter. It had a normal inlet and exhaust valve plus a small auxiliary inlet valve which provides a relatively rich mixture near the spark plug. The remaining linear air-fuel mixture is drawn into the cylinder through the main inlet valve. The volume near the spark plug is contained by a small perforated metal plate. Upon ignition, flame front immerse the preformation and ignite the remainder of the air-fuel charge. This combination of rich mixture near the spark plug and the lean mixture in the cylinder allows stable running. Complete combustion could be achieved with reduction in CO and CO, means carbon monoxide and ACO hydrocarbon emission. It may be noted that these were carbureted engine and the relative imprecise nature of such system limited their application. Next is, after the Honda Lindbergh, next is Mitsubishi Ultra Lindbergh engine. The Ultra Lindbergh control system developed by the Mitsubishi is shown in this figure. It uses a catalytic converter to reduce NOx emission, as air pollution has become more important to automotive companies and government. The Lindbergh combustion technology is being developed and improved. Mitsubishi have created a Lindbergh engine that will operate a 40:1 air-fuel ratio mixture. It may be noted that the Ultra Lindbergh mode is not used for starting or accelerating the vehicle. For this task, the engine uses a superior output mode, which is a linear mixture. The reason is that the Lindbergh techniques is not used during the startup. In this, because more hydrocarbon and carbon monoxide emissions are created at this stage. This means that there is no advantage in using the Lindbergh to lower the performance engine at the startup stage. The Ultra Lindbergh engine does, however, contain a new technology. Instead of making the air-fuel mixture spiral around the combustion chamber, the Mitsubishi injector forces the mixture to tumble clockwise in the chamber, using upright and straight intake. So this system breaks up as the piston compresses, forming eddies that push the fuel even closer to the spark plug. The newer injector system has also been introduced, which provides a more reliable source of ignition for the Lindbergh engine. The certified charge system optimizes the fuel across the spark plug, and the particles of fuel produced are much smaller than conventional processes, less than the 9 micron as opposed to 27 microns in a high pressure direct ignition system. So this is the Mitsubishi Ultra Lindbergh engine. Now comes to the advantages of the Lindbergh engine, that it has higher fuel economy. It emits fewer unburned hydrocarbon and greenhouse gases. A Lindbergh mode is a way to reduce the throttling losses. And what are the disadvantages? Disadvantage is that a complex catalytic converter system is required to reduce the NOx emission, and it is relatively costly. It is high cost. So in this lecture sessions today we will learn about the Lindbergh system, its principle, is how it controls the emission. Then we'll go study the Toyota Lincoln engine, Honda Lincoln engine, Mitsubishi Ultra Lincoln engine, and its advantage and the disadvantage. So till now, thank you so much, classes.